So, we're all lucky enough to have Martin J. Osborne writing game theory textbooks. We're going to be going over an introduction to game theory. Not all of it today, because it's like 700 pages, but we are going to be going through a handful of questions and answering them. Now, the copy that I have here, I found it on the internet, and you can just download the PDF version from 2000. So I don't know how up to date it is, but he has a website. I highly suggest you check it out. On further inspection, I'm not sure what I'm allowed to do with this textbook because it says no part of this book may be reproduced by any electronic or mechanical means, including recording or information storage and retrieval. I just don't really know what the deal is, but I think I'm gonna go ahead with what I was planning on doing and then ask for forgiveness later. I'm not gonna be reading you chapters or anything. Like, we're gonna go through like exercises and thinking about solves, you know? Here's the plan. I'm gonna link the textbook in the description of the video. I highly suggest you go check it out. And then I'll be selecting exercises from the textbook that we can solve. And again, these are not my questions, these are not my exercises. This is all Professor Osborne's. So the first exercise we're going to go through is player 1 cares about their income and about person 2's income. Precisely, the value she attaches to each unit of her income is the same value she attaches to any 2 units of person 2's income. How do her preferences order the outcomes 1, 4, 2, 1, and 3, 0, where the first component in each case is person 1's income and the second component is person's 2 income? Give a payoff function consistent with these preferences. Okay, so this is what I do. So you've got 1, 4, 2, 1, 3, 0. Okay? These are your 3, and this is player 1, this is player 2, okay? So these are our 3 payoffs right here, where the first number is player 1's payoff and the second number is player 2's payoff, okay? So in this case, we want to develop a utility function that accounts for player 2's income at about half the weight, right? Half the payoff. So I'm going to let x equal player 1's potential gain and y equal player 2's potential gain, okay? And so your utility with respect to x and y is equal to a full x plus 1/2 of a y, okay? Or you could write x plus 0.5y, okay? So this story is consistent with our game. So to solve this, to figure out what player 1 wants, we just need to find their highest utility. So in this case, well, x goes to 1, y goes to 2, this equals 3. For this one, this is 2. This equals 2.5. So therefore, 1, 4 is greater than 2, 1. And then 3, 0. Well, this is also 3. So therefore, 3, 0 equal to 1, 4 greater than 2, 1. And so therefore, these are equally rational choices for player 1 to make. So player 1, indifferent. Excuse my lousy handwriting. but player 1 is indifferent between the payoff 3-0 and 1-4 because player 1 still cares about half as much about player 2's outcome. And that's all I'm going to do today because I don't want to get in too much trouble. But I think it is kind of fun to solve these and to put them on YouTube. None of my videos are monetized, and they never will be, let's be honest here. But if they ever do get monetized, I don't need the money for the videos. So I'm happy to not make any money ever off this. This is just for myself, really. So, but anyway, I'll put the textbook in the description of the video, so please check it out. It's really, really good. Thank you for watching.